Hi everybody, it's Miss Peachy from your WCA physical science class, and I'm going to be talking with you a bit about radioactive decay with the nuclear chemistry unit that we have been working on. So we're going to kind of go through what radioactive decay is and half-life, and look at some half-life problems here in the next few minutes. And this is your supplemental for the virtual class for this particular concept here. And well, I guess we can go ahead and get started with what that is. I'm going to go ahead and turn your attention to my notebook. Handy dandy. And flip the screen so you can see better. Okay, so I'm going to scooch this over this way. Okay, perfect. Maybe turn a light on here so you can see better. So first of all, let's talk a little bit about what half-life is. Now, earlier in a previous tutorial, I went through with you what alpha and beta decay are and kind of did some practice problems with those. And so now we're going to be looking at how long it takes for all of this to happen. And half-life is a unit of time. I'm going to use my Think about the length of anybody's life. Let's say your life is 80 years. Then half-life would be 40 years, right? So it is a length of time. Different nuclear isotopes, different radioactive isotopes, are going to have different lengths of half-lives. And that's going to vary from fractions of a second to billions of years. So we have a large variation in the half-life. We oftentimes look at carbon-14. Carbon-14 is a very commonly used radioactive element in examples. And I'm just going to verify the half-life because I always mix it up in my brain. I always change the order of the numbers. But the half-life for carbon-14 is 5,730 years. Carbon-14, I believe it undergoes beta decay. So it's going to emit a beta particle. If you remember, beta particles mean that it gives off an electron, but then it also gives off or changes a neutron to a proton, so it actually increases in atomic number. So it's going to become nitrogen-14 after it undergoes radioactive decay. So carbon-14, this is the parent element. And the daughter element or daughter isotope is nitrogen-14. This is stable, so it's no longer going to decay anymore once it gets to that. Carbon-14 is radioactive, nitrogen-14 is stable, so it's changing, okay? So remember, the 14 tells us it's the mass number that doesn't change when we undergo beta decay. What does change is just the atomic number, and it goes up by 1, okay? What we're saying with half-life is that if I had a chunk of carbon-14 and I waited 5,730 years, approximately half of that carbon-14 would still be carbon-14. The rest would be, the other half would be nitrogen-14 after 5,730 years have passed. It'll be a ratio of 50-50. Now, that's one half-life. So one half-life for carbon-14 is 5,730 years. And we can say that 1/2 of the original carbon-14 remains at that point in time. A second half-life would pass after an additional 5,730 years. So if we added an additional 5,730 years here, which when we add these together, it's 11,460 years. So after a total of 11,460 years, 2 half-lives, the amount of carbon-14 that's going to remain is going to be less than half. We have to take that half now and divide it in half. So I'm going to use these stickers to kind of cover up some of my... So we're going to take this and we're going to divide it in half. So half of that is now nitrogen 14. The other part is carbon 14. So we can say that only a quarter of what we started with is carbon 14. This is the amount of carbon 14 remaining. Now we can say, well, let's go on another 5,730 years. Total of 17,190 years. That's 3 half-lives. We have to now cut this piece in half. So let's do that. We're cutting this piece in half right here. We now only have an eighth of my original carbon 14. The rest is nitrogen 14. And we can keep doing this. Another 5,730 years later. Oops. Well, we start with 17,190 plus 5,730. That's not right. Apparently I cannot use my fingernails. $22,920. That's 4 half-lives. Okay. We're kind of running out of space here a little bit. But I'm going to go ahead and cut this box in half one more time. Why not? All right? Okay. So I only have a half of that. That's carbon 14. So just 1/16 of the original. Okay, can you kind of see the trend here, right? So there's a little bit of math we can do. Make this a little easier. Whatever the number of half-lives is, that tells us how small to go with what's remaining. This is what's left over. So if I look at it like this, it's 1/2 to the n power. N is the number of half-lives. This tells us the fraction remaining. So if I have 3 half-lives, it's 1/2 or 1/2 to the third, which would be 8, 1/8 remaining, okay? That keeps you from having to do step by step by step by step. I could go for 50 half-lives, and that would give you an idea of how little is left after that much time. So let's look at an example. One example here. So I have an example that says mercury 197. Is used for kidney scans and has a half-life is 3 days. That's the half-life. It says that the shipping of this mercury, they order the mercury 197 for their hospital, and it takes 15 days to get there. They ordered 32 grams of this stuff. They want to know how much is going to be left when the shipment arrives. So the first thing you're going to do is you're going to figure out how many half-lives the shipping takes. Well, it's 15 days. 15 days, but each half-life is only 3 days. So it's taken 5 half-lives. Okay? Then we're going to go back to the formula that we just made before. The fraction remaining, 1 over 2 to the n. 1 over 2 to the 5th. Okay? What's 2 to the 5th? Well, let's look at our calculator and figure it out. Only 1/32 of the original is going to be remaining. That's the fraction. Well, if I started with 32 grams, what is 1/32 of 32? 1/32 of 32 is the same as taking 1/32 times 32, which is basically 32 divided by 32. Gives us 1 gram remaining. Not very much. I would hope that they would have to get some sort of express shipping, because I don't think that 15-day shipping is really worth it when you have such a short half-life on your radioactive element. All right, so these are the types of problems you're going to have to do with half-life. If you have questions or concerns or need any additional help, please give me a call at extension 2204 or send me a webmail message. Have a fantastic rest of the day, everybody.